Hi everyone. Sorry I had to be gone today, but you're going to have to make do. And we are starting section 4.2. Yesterday we covered 4.3, so maybe start by having that homework assignment out. Answers are shown right here, and I'm going to read them off for you real quickly. So question number 1, you should have started at the point -2, 5 and gone down 6, right 1. Question 3, you should have started at the point right 4, past 4, up 3, and the slope is down 1, right 2, because it's -1/2. Question 7 is y equals 4x plus 34. 9 is y equals x plus 13. 14 could be read in a few ways. It could be read as y equals 6. It could be y minus 6 equals 0. It could be y equals 6 plus 0 times the quantity x plus 7, because the slope is 0, and you're doing that for every x past a -7. Past a -7 makes plus 7. 18 would just be y equals 0. 31 would be y equals 1/6 x minus 8/3. You could write the y-intercept as a decimal if you like, but you should always use your slope as a fraction. 41 is written in regular point slope form like the rest of the world does right here, or you could also write it in Bruin point slope form. Either one's fine. 47, same as done here. You can write it in regular point slope form. You can write it in Bruin point slope form, but then when you simplify it to y equals mx plus b slope intercept form, you get the following. 53 was meant to be a little bit of a challenge. If you got it, awesome. If you didn't, don't worry too much about it. It was supposed to be one that kind of just tested you. 73 and 75 was practice solving for a variable. 73 is a equals the quantity v minus r all divided by t. 75 is b equals -t plus 5 divided by 4. So there are your answers to section 4.3. With that homework out, at the bottom, I'd like you to try these warm-up questions. Number 1, find the slope between these 2 points. We're going to use that a lot today. Question number 2 and 3 have to deal with this table, giving you a sequence of points, giving you the term, and then I'm giving you the value at that term. So, at term 1, the very beginning, it's 4. The next term 2 is 9. Then 3 is 14. 4 is 19. You can use this pattern, fill in the next 3 values for the table. And then can you find an equation for the nth term and then use that equation to find the value of the 50th term. So pause the video now, give everyone maybe a minute to try these questions, see how you did, and then come back once everyone's had a chance to try. Okay, let's see how we did. For question number 1, we're going to be using our slope equation a lot today. That slope is equal to y2 minus y1. We call that the rise, divided by x2 minus x1. We call that the run, how far apart my y's are. That's how much I go up and down compared to how far apart my x's are, how much I go left and right. We call that the run. In this case, this would be x1, this would be y1, this would be x2, and this would be y2. So this is going to turn out to be 4 minus a -1 is going to make a +1. All over x2 is 0 minus 2. I end up with 5 divided by -2. You'd probably see the book just write this as -5/2. They put the negative out front. And most people, when they graph it, would actually go down 5 and right 2. Or you could go up 5 and left 2. It will give you the exact same line. Question number 2, you should have picked out that the pattern is add 5, so the next 3 values would be 24, 29, and 34. And then can you write an equation for the nth term and use it to find the value for the 50th term? Well, this is actually Bruin point slope form. You can think about it by saying maybe the value is equal to, let's pick one. It doesn't matter we could pick any of these. Let's use 3 and 14. The value is 14 to start if I use this point, and then I go up 5 for every term past the third one. Let's check and make sure that this works before we use it for the 50th one. Let's do it for the 5th term. If I put 5th term in there, for term I put 5. 5 minus 3 is 2. There's 2 extra terms past the third one, so I have to add 10, and that value would be 24, and that's exactly what it is when the term is the 5th one. Now I'm going to use this to do my 50th. So the value is 14 plus 5 times 50 minus 3. Value equals 14 plus 5 times 47. Then you grab your calculator, probably type in 5 times 47, find out you get 235. If I add 14 to that, I'm going to be at 249 as the value of the 50th term. So they can use this Bruin point slope idea for larger patterns. There's other ways you can do it too. You can actually work backward and figure out what it would be if there was a term 0 and kind of do it in y equals mx plus b. But I think this is probably the most natural. So there you go. You need your note packet now out to section 4.2, which says writing equations in slope-intercept form. So have your note packets out. If we need to pause the video, make sure everyone's ready, then do so. Otherwise, I'm going to assume we're good to go. So lead-in question, how does our Bruin point slope form that is shown right here, how does it change when we start with an x-coordinate of 0? For example, let's say you start at a y-coordinate of -4, go up 2 over 1 for every x past x equals 0. So let's translate. Y is -4, go up 2 over 1 for every x past 0. Well, this is what it looks like in point slope form. If I simplify, x minus 0 just makes x. I get y equals -4 plus 2x. That'd be the same as if I wrote this as 2x minus 4, and you might recognize these forms. These are slope-intercept. So the nice part about point slope form is that it will naturally fall to y equals mx plus b if your x-coordinate is 0. It will naturally just translate to that situation. I can then graph this. Start at -4, go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. I've got my points. I draw on my line. And naturally, point slope form will go to y equals mx plus b. Y equals mx plus b is a special case of point slope form. It's the case when your x-coordinate is 0. That's why we learned point slope form first, because then slope-intercept y equals mx plus b will just naturally fall to it. So when we want to graph and we already have the y-intercept, that means our x-coordinate is 0, we can automatically go to slope-intercept form because we know it's going to be for every x past 0, and we don't need to write that. It doesn't matter to me if you write it as y equals b plus mx or y equals mx plus b. You just need to make sure that b is standing for your y-intercept, m is automatically then implying your slope. What changes if you write it in function notation? Absolutely nothing. You just give it a more specific name, like f of x. f of x equals b plus mx, or f of x equals mx plus b. The benefit of using function notation is if you had multiple equations or multiple graphs, lines going on in the same graph, you would know which one you're talking about instead of just calling them both y. So nothing's going to change. Example number 1, write an equation of the line with a slope of -2 and a y-intercept of 0. Since you have a y-intercept, or sorry, not of 0, a y-intercept of 5. Since you have a y-intercept, you know your x-coordinate is going to be 0, so you don't need to write past 0. So we can just write slope is -2, y-intercept is 5, and we would write y equals 5 down 2 over 1 for every x. Past 0, I don't need to write it though. I would just leave it like that. You could also write it -2x plus 5. Either one is fine. So there you go. Example 1 done. And just like that, we're on our first whiteboard question. So pull out your whiteboard. This should take you all of maybe 30 seconds to a minute, because you're going to have to find something at first and conduct the following question. Write the equation of the line that goes through the point 0, 3, and 1, 7, and then simplify the slope-intercept if you need to. Or if you're clever, you can figure it out without having to simplify from Bruin point slope. So pause the video now. See if you can pick out what the y-intercept is. Can you figure out the slope and then write it in slope-intercept form? So pause the video for about a minute. Give everyone about a minute to try. Okay, you'll realize the first thing we need to do is find the slope. So I'm going to end up doing 7 minus 3 over 1 minus 0. That's going to give me 4. Then I need to see, do I have the y-intercept? And I do, because this is the y value and x is 0. My y-intercept is 3. So I would write y is 3. I go up 4 over 1 for every x past 0, but I don't need to write past 0, and I'm done. Y equals 3 plus 4x. Would be the same as if you wrote it as 4x plus 3. Either one of those is fine. So you got to find the slope first if they don't give it to you. Example number 2. This says, write the equation for a line in slope-intercept form that goes through the point 3, 1 and has a slope of 2. First, how is this different than the past 2 examples? Well, the difference is the past 2 examples, one of the points was a y-intercept. If I look at this, this gives me a slope, so I know that, but I don't have the y-intercept. I just have another point. And so I'm going to need to translate from that piece of information to get to y equals mx plus b. And there's two methods to do this. One, you can write it first in Bruin point slope form and then simplify, or some other point slope form. You can do regular point slope form too. And then method two is write it in y equals mx plus b form and then solve for the missing y-intercept. I'm going to show both because some people really prefer one over the other. So I would encourage you, though, to write down both methods, and then you can choose once you have an example of each. So here's method number one. Write it in Bruin point slope at first and simplify. So I would say this is an x coordinate, this is a y coordinate. So I would say y is 1 to start. My slope is 2, so I go up 2 over 1 for every x past my x coordinate of 3. That right now is not in y equals mx plus b, but I can get to it just by simplifying. So step 1, Bruin point slope. Step 2 is going to be simplify. So I'm going to distribute that 2 through. I then get y equals 1 plus 2x minus 6. Now I just simplify by combining my like terms of 1 minus 6. That makes negative 5. So I'd say y is negative 5 plus 2x. And now I have it y equals b plus mx. You could write it as y equals 2x minus 5 as well, if you preferred that. So there's method number one. Write it in Bruin point slope and simplify. Now I see my y-intercept is negative 5. Here is method two. Method two is to first write it in slope-intercept form and then solve for b. So let's say I'm trying to get it in y equals mx plus b form. I know from the given piece of information that the slope was 2. So I'm going to write that in my equation. I know it looks like y equals 2x plus b. I don't know the y-intercept. Do I know an x and a y that go together that are on the line? Yeah, 3, 1. 3, 1 is a point on the line. 3 is an x coordinate. 1 is a y coordinate. So I'm going to put 3 in for x, and I'm going to put 1 in for y. I will then get 1 equals 2 times 3 plus b. That leaves me at 1 equals 6 plus b. I subtract 6 from each side, and I get negative 5 equals my y-intercept. Now I know the y-intercept, I know the slope, I can write the entire equation. It's y equals 2x minus 5. I know m and I know b, so I can write the entire equation. So those are just two different methods of getting the exact same answer. Going to give you a chance to try it. So pull out your whiteboard, exact same process, just to make sure that you can do it. A little chance for self-assessment. Use the example we just did as a guide. You're going to be asked to do multiple ones like this in the homework. So maybe pause the video now for a minute. Try both techniques just this once, and then going forward, it doesn't matter to me which one you choose, but try them both on this one. And then unpause the video once everyone's had a chance to try. Okay, here's method number one. I would say y is 5 to start, down 2 over 1 for every x past 2. Now I need to simplify it. Distribute my negative 2. I end up with negative 2x plus 4. Combine my like terms. I get then 9 minus 2x. So there is method number one. Method number two would be start by writing y equals mx plus b, but I know m is the slope, and m is negative 2. Now I use 2 as my x and 5 as my y, so I'll put 5 in for y, and I put 2 in for x, and I'm trying to find the y-intercept because this is a point on the line that is not the y-intercept. I then get 5 equals negative 4 plus b. Add the 4 over the other side, and I get my y-intercept is 9, which is the exact same thing I got over here. And then I write my entire equation, negative 2x plus 9, mx plus b. Exact same answer, just two different ways of doing it. Last point is, what if they give you the information in the following way? They say write an equation for the linear function f with the value of f of 9 is negative 2 and f of 4 equals 3. Well, recall in function notation, the inputs are x's and the outputs are y's. So this right here is really just the point 9, negative 2. This right here is really just the point 4, 3. So it would be the exact same problem as if they said write an equation for a line that goes through the points 9, negative 2, and 4, 3. I will ask a question on an assessment that looks just like this, just to make sure you understand the notation. There is no different mathematics going on, it's just how they supply the information. Well, if I look, unfortunately, neither one of these is the y-intercept, and they don't give me the slope. So I'm going to have to solve for both. So I need to first find the slope. Slope is equal to, this will be x1, y1, x2, y2. So this is going to be 3 minus a negative 2 makes plus over 4 minus 9. I then get 5 divided by a negative 5, and a positive divided by a negative makes a negative. So I know that my slope is equal to negative 1. Now, I need to find the y-intercept. So I'm going to do that on the next page. I found my slope is equal to negative 1. And then I can either do Bruin point slope and simplify, or I can write in y equals mx plus b and solve for b. I'll show both right here. So Bruin point slope and simplify. I would say that my y coordinate, doesn't matter which point I choose. I can use either one. Maybe I'll use the second one. My y coordinate for this point is 3. I go down 1 over 1 because that's my slope for every x past 4. I simplify by distributing the negative. Then I combine my like terms of 3 and 4, and I get y is 7 minus 1x. They asked me to write it in function notation, so I would say f of x is equal to 7 minus 1x, or just 7 minus x is fine. So there's method number 1. Method 2, y equals mx plus b, but I know that m is negative 1. Then I can use either point. Just to show you, I'm going to use the first one on this second method. So negative 2 for my y equals negative 1 times 9 for my x coordinate plus b. I get negative 2 equals negative 9 plus b. Add the 9 over the other side. That makes 7. And I get my y-intercept is 7. Then write it in function notation. You can call it anything you want. I call the last one f. Let's call this one g. G of x is, negative 1x plus 7. And that's the exact same equation I got on the first one. So there you go. Sometimes they might not give you the slope or the y-intercept. You have to solve for the slope by using the slope formula. Then you have to get the y-intercept either by doing Bruin point slope, simplifying, or writing in y equals mx plus b and solving for the y-intercept. There are tons of examples in the book to go off of as well, but that is it for today. You would then be in the section that has homework corresponding to section 4.2. I believe that is day 7 on the assignment sheet. Answers are right here. Thank you very much. Have a good day.